All right.
boy.
Hey, Tyler.
All right. Looks like
Hi.
we have a guest.
I guess. Thanks for having me. Appreciate being here today. Gonna talk about Graviton, which is like my all-time favorite thing in the world. So, I do have one issue, Gigi, though. You called Art a star, and we got to be careful with his ego because dude's already trying to go retire in the Bahamas somewhere, like Jamaica or Aruba.
I mean, he's
so
dressed for the Bahamas with his with his blazer today.
Yes, he is.
I'll raise you a tropical themed plaid. I'm
There
gonna
you
sleep blazer.
Looks like he's
All
ready
right,
to go sip a
everyone.
Mai Tai in Montego or somewhere.
Yeah, is it linen, Art? Is the blazer linen?
There's too much shade, and I know I'm not 100% sure whether it's linen or not, but it is a summer jacket, and it's cold in the office. But before we go any further, Gigi and I have had the opportunity to introduce ourselves. Tyler, why don't you introduce yourself and what you're here to talk about as well?
Yeah, so my name's Tyler Jones. Great to meet everybody on the audience. I'm a senior solutions architect here at Amazon. I specialize specifically in what we've dubbed our efficient compute initiative. So that is our AWS Graviton powered instances in Spot. I've worked very closely over the last 3 years with the Annapurna Labs teams, bringing Graviton feedback from customers to them and kind of helping morph the roadmap. And so today I'm going to talk about our Graviton 4 processor, which just launched yesterday or earlier this week, and is now generally available for everybody. So that's what I'm going to talk about today. Super excited, kind of a hardware nerd. And so love it when we can do some of this stuff.
Yeah,
I'm
I want to,
very excited.
right? So this is pretty cool.
Yeah.
I want to, for those who have just joined us and may not know, I want to demystify some of the things that Tyler said, because I think you used a lot of terms that I'm not sure everybody will know.
Yes, I'm sure I did.
Right, so we'll start with Annapurna Labs first. Who are they, other than a really tall mountain if you look it up out there? Annapurna Labs is our chip group, and they are a subsidiary of Amazon Web Services, and they design and develop computer chips here at Amazon. So it's a great, it's the group that designs our computer chips.
They do all of our custom silicon, from
all of the custom
to
silicon,
Nitro chips, everything.
Right. So, and then if you've used Amazon or worked on Amazon before, we also have our own Graviton chips, and that's our CPU chips. And maybe Tyler can give us a little bit more information about Graviton and the Graviton family.
Yeah. So when we say Graviton chips, we don't mean, sadly, the potato chips, although we did have a really cool bag at reInvent that I actually have behind my shelf, like right there, where we made it look like a bag of potato chips, which is really cool. But they're general purpose processors. They're used for anything compute related, equivalent to like Intel or AMD CPU. Selfishly, I think they're cooler, but that's just my opinion. So yeah.
It's just one man's opinion. So when you guys say, I'm gonna be the normal person in the audience here who isn't super deep on this. When you guys say that Amazon develops anything, it's all of our silicone production. It's our chips, it's our processors. How far does that span, and where do those items end up when they are built?
Yeah, that's actually a really great question. It's one that not a lot of people ask. So specifically with Graviton, we license some of the intellectual property and general designs from ARM. And so they're an ARM-based processor. And then we actually get to decide specifics. How many cores do I want in the processor? What do they look like? What does the actual layout look like? Stuff like that. That's really where we handle the design. And then we do deal with the manufacturing and building ourselves. And so we can bring that to market. We did that largely because customers were pushing us to innovate faster. And so instead of being beholden to Intel's roadmap or AMD's roadmap, we decided, let's go try taking a crack at this ourselves. We have some very specific design ideas in mind. We want to design specifically for the cloud, for cloud-based workloads, and really narrow in on that. And we landed on a processor and a family of processors. It's really all about nailing the best price performance on AWS. And so price performance, I know, is a term and we use a lot. I'll define it. It's really how much performance can you get for every dollar you spend. And Graviton really leads the way in that category in AWS.
Yeah, I want to make stats because I love stats, Gigi. We have at Amazon, little known fact, we have shipped over 20 million computer chips that are used entirely by Amazon Web Services.
That's really cool.
Right. And that's
so many
all of our processors together. So that's the Nitro system, Graviton, and our Trinium and Inferentia processors collectively together. And that comprises that up. So I think that that's a pretty cool stat as well. And I think that as we talk about this, like the other thing that I think Tyler didn't mention about the Graviton processors is that our last 2 generations, we've also talked about the sustainability. And Gigi, I think you and I have talked about this on a couple of shows about how the importance of efficiency provides performance improvements to people. So efficient design provides a performance improvement, but efficient design also, that layout makes us efficiently use the power that is provided. And as we said in our intro here, R8G are the most efficient chips and the best price performance chips that AWS has ever designed. So, and given the performance improvement that we have had over time, that's a pretty lofty goal.
That's really, really cool. I will say my dad called me today and said, I heard Amazon's doing a really good job when it comes to the AWS sustainability improvements. And I was like, you're not going to believe it, but that's what we're talking about as part of our live stream today. So shout out to my dad if he's watching. He normally does.
Shout out to
Gigi's dad in the chat.
All right, there you go.
He's our biggest fan, aside from Todd and AM chatting in the chat today.
So I think it's time to do a demo here, Tyler, and show people a little about the performance.
Yes.
And, I'm excited because I have had the privilege of working, Gigi, with Tyler and a couple people before in the Graviton team many times. Shout out to Marcus and Arthur Petit-Pierre as well, who we kind of collectively wanted to showcase some of that performance. So Tyler, why don't you bring up that as well to get to,
I'm gonna start with a couple of slides real quick first that just kind of we'll talk about Graviton 4. I've got pretty graphics.
Thank you.
So we have Graviton. We started back with the very first chip in Graviton, and now we're up to Graviton 4, which is our 4th generation, just 5 years. You'll notice we're anywhere between 25 to 40% performance improvement generation over generation, and we're continuing that trend with Graviton 4, 30% better compute performance. We actually added 50% more cores per chip, which is pretty dang impressive, and added a boatload more memory bandwidth. So between Graviton 3 and Graviton 4, Graviton 3 has 64 cores and a chip about yay big. Graviton 4 has, we pack a whopping 96 cores into that. I remember back in the day, I got my very, very first quad-core server processor, and it was like the size of my iPhone. And I was like, oh man, this is so cool. And now we have 96 in a smaller space. So really impressive what we're doing with it.
Hey, before you leave that slide, I just want to make one point about this, is that because we threw out this number up to 30% better compute performance and 50% more cores. But if I'm not mistaken, it's every time we put the up to better compute performance number, it's over the prior generation. So this 30% is not 30% better than the first A1 version of Graviton. It's 30% better than the Graviton 3, which was 25% better than Graviton 2. And so you can see the really significant kind of asymptotic, if you will, performance improvement that's happening here, which I think
it's impressive. Like we've basically 4x'd compute in 4 generations, our capabilities, which is really impressive, and especially when you look at some of the other offerings out there, not accelerating nearly as fast. So
exactly. And I also want to emphasize that, if you can go to your next slide, so we run through the slides quickly. But the other side of this is this is a direct response, Gigi, to customers who have asked and need this performance improvement here. Here we go. A little Venn diagram.
Perfect little animation right there. Graviton 1, we did stuff. Graviton 2, they said, oh, we need more performance. Graviton 3, people were all about, well, I want even more performance, HPC, all the fun stuff with ML out there. And then we did all that. We delivered it, and they said, okay, great. But you guys only go up to 16XL. I need more. And so Graviton 4 really fits into that. We can now go to 128 cores, 96 times 2 is, let me see. I can't math in my head anymore. So 192 cores and a 1.5 terabytes of memory. on our R8G 48XL. So we're really pushing the capabilities, like Art was saying, directly in response to customer feedback. And that's the best thing about Graviton is we control the roadmap. So if the customer screens at us and says, hey, you're not doing good enough here, we need more, I can actually go take that back to the engineers working on the next generation and say, how do we fix this for Graviton 5 or Graviton 6 or, whatever generation we end up on?
How would you say that, like, in a tangible example, the jump from from 3 to 4 has impacted our customers? Like, are they able to do things that they physically couldn't do, or are they doing it just so much faster and saving X amount of money?
Both. Definitely both. They're doing stuff faster. And then the other piece is a lot of customers are coming to us. They have these, I'm going to call them more legacy databases, things that weren't necessarily designed with a cloud in mind. So they need to scale up, meaning each machine needs to have more processors, more memory, rather than running a lot more machines. And with Graviton 3, we were capped at a 16XL. And some of these customers were coming to us, they were already running 24XLs or 32XLs on other instance types. And they said, we want to go to Graviton. We love Graviton. We love that it's more energy efficient. We love that it's more sustainable. It'll help us achieve our sustainability goals, but we need a bigger instance size. And so we didn't have an offering until earlier this week. We do now. We're already starting to see some customers have really strong interest in those larger sizes. And then additional customers, and this is kind of what I'll be demoing here in just a sec, who are running Graviton 3 need a little bit more performance. They want to upgrade to Graviton 4 and get some of that 30% generation over generation performance improvement.
So I want to push us to see this demo. And
yes, this is actually my last slide, so this is perfect. Check the time.
So check. And then I just want to bring up something else, BG. Until I joined Amazon, I don't know that I always understood our vernacular about whatever 24XL, 32XL, or something like that. So I just want to mention, as Tyler, you can bring up the demo as well, as just that.
Yeah.
We offer people different slices of CPU, and the sizes are registered in what we characterize as t-shirt sizes. So we have everything from, some of our smaller sizes are, if you wanted to try Graviton out for free, for example, you can use our T-Series small size, T4G on the small size. You can get a hold of this for free. But that gives you the ratio of the amount of memory to the amount of compute that you get. So what Tyler has been articulating here is that with the advent of Graviton, there are some customers that have really wanted a lot more access to a lot more cores and a lot more CPU. And in this case, the 24XL, which corresponds to the largest t-shirt size, the largest size that we offer there, offers you 96 cores. So anybody that's interested in the 96 cores for Graviton, this is your opportunity. And it shows that ratio of the memory to compute. The other thing that we're noting is that today we're announcing R8G, which is our memory optimized instance. So this is the largest amount of memory to vCPU ratio of our M, R, and C category. And to answer the other question that people may have, why did you start with R? Well, back to the thing Tyler was talking about, this is what customers have asked us for in particular. So we have prioritized the workloads that customers have wanted to deliver here to everyone.
Got it.
All right. Sorry. Time for
you're good. That's great. So I want to show, I'm going to do a little pre-cooked demo show here. And so these are actually my ingredients. You'll notice I'm running a web app on R7G, which is a Graviton 3 instance right now. This application is really simple. It's a URL shortener. So if you've ever used Bitly or something like that to send a short link, all it does is it does that, generates a unique thing and stores it in a database. So if I want to actually send a request here, I click send, and then I get a short URL, so I could send a short URL back. And then if I wanted to get back later, I'd have a fancy little API. So that's what happens. I'm going to just show and prove that it works in real time. I'm not staking anything here. So let's talk about performance. So I've got a pre-built little load test right here. I'll send across. This is going to start loading my Graviton machine. If I need to start my web application role first.
I think this is proof, though, that we're definitely doing it live, GG.
Yes, we are doing it. We're doing it live.
For sure doing it live. Can you zoom in for my eyes?
Yes, I can. This is fancy terminal. So right here, you'll see my R7G
you.
running. You'll notice a lot of activity across my 16 cores right now. I'm running just a short in this window, just a short little, 60-second load test. And I'm throwing 3,600 requests per second at it, 60 different connections at the same time. And so this is just simulating, if I actually ran a link shortening service, kind of something that I would look at. So one of the things I was going to demo here is just the performance that we're going to get. And then the other thing is I wanted to demo as soon as this load test is done, I'll show how fast it is to move from Graviton 3 to Graviton 4. Customers initially are very familiar with our products moving from 5th Gen C5 to C6i instances. And they always ask, how do I go to Graviton 3 to Graviton 4? So you'll see right here, this is kind of my latency distribution. This is roughly the response times in different distributions for things. So I'm anywhere between 6.83 milliseconds in the 50th percentile up to, we'll say, 17.5 for 99% of my requests. Really good response times already. So I'm going to go ahead and shut this one down real quick.
Should we, while you're bringing up the R8G version, maybe we should also tell people what, if they don't remember some of their what their high school math teacher may have informed them about these percentages here. Yes, so the percentage that Tyler was putting on the left there is what percentage of requests fell under the amount that was there on the right. So when he says 99% happened, that means 99% of all the requests happened in under 70 milliseconds. And you can also see the incredible number that are happening below 6 milliseconds as well. I think that was, memory serves correct, I think we were at 40% or so. So a little bit of variation, but that's what Tyler was displaying, is that 99% of everything was happening in under 90 milliseconds. And I think it was, 40% or so was happening in the lower ranges there. So it's pretty kind of cool. So anyhow, I interrupted here, but I don't know if everybody...
No, that was actually a perfect filler because it gave me time. So the console right there, all that we have to do to migrate to the new Graviton instance, if you're on a running Graviton instance, is stop the instance, change instance type here, and we're just going to spin up an R8G 4x large. And just like that, we're on a Graviton 4 instance. I'm going to start the instance.
Oh, cool.
And as soon as it boots over here, I'll reconnect to it. And that's it. Congratulations. You just moved your entire hardware underneath. You went from Graviton 3 to Graviton 4.
It's the easiest migration demo I've ever seen.
Frankly, I was fingers crossed it works the whole time, because you never know when you're going to run into some weird snag. And that's really the power of AWS and the systems we built because of Nitro, things like that. Our ability to do these kinds of migrations are just impressive and second to none. So start my web app here. And then pull up our CPU graph again and zoom in for you. And then to prove it still works, I'll rerun this load test and you'll see load come across right here. And literally that fast. We did it live on air in less than 5 minutes. We moved from Graviton 3 to Graviton 4. And what did we get out of that? We get 30% better performance, most energy efficient processor we've ever run. So makes your CFO happy, makes you happy. Everybody's happy here. So
I'm happy. Are you happy, Gigi?
I'm smiling. This is so cool.
First of all, this is the fastest I think anybody has done a migration on AWS OnAir. I think
it's the fastest demo anyone's ever done on AWS OnAir. Like your middle name is Speed Demon because you're just
there you go. I like
moving at lightning speed.
So yeah, we move quickly here. We've done so much engineering work to make this as fast and simple for customers as possible. If you're using tools like Kubernetes, we're talking, a couple of clicks and you're already moving. And so this is the latency distribution we just saw in Graviton 4. Really good performance numbers. More than 75% of all of our requests are in under 8 milliseconds. 90% are coming through in under 10 milliseconds. Really impressively fast. If you have workloads that are CPU bound today, meaning a faster CPU means a faster application. Graviton 4 is where it's at. It's going to be really impressive here. I'm super stoked about it. Stop by our booths at reInvent. You can actually hold on to the actual chips themselves. One of the things we do each year. So, like I said, I love Graviton. I think it's one of the coolest things in my career I've worked on to date. So,
if you and Gigi, if you didn't love Graviton before, everyone loves Graviton now, right? Come on.
Yeah, I now have a soft spot in my heart for Graviton, and I will be visiting the booth event to touch a chip.
Yeah, we have one of the things we actually show those chips. So I encourage you to stop by. We started that the last couple of years to be able to show people that. We also have server racks as well, so people can take a look at that. And we're going to we'll do even more demos on R8G. And for those, since I can remember just in the demo here that originally 90% were sitting at about 90 milliseconds or so in our 7G. And so if you look at the 99% number here that Tyler showed, we were at 68%. So this is some pretty substantial improvements if you aggregate that out, because this, time is money. I think a lot of us as engineers love things to be faster and faster. But I think, as Tyler mentioned, your CFO will be just as excited that this is happening at a lower cost, and also meeting and helping you meet your efficiency targets. So I think that those are kind of some amazing things that have happened there.
Yeah, thank you so much, Tyler, and thank you for breaking the record for demo time on AWS OnAir. Looking forward to our production team adding you to the list.
Yeah, super stoked. Thanks for being here. Really excited to hear more and more customer feedback about Graviton. We've seen amazing stuff. 33% better XG boost ML performance, which is great. So I want to hear more stories about that. So if anybody has them, I'd love to see them in chat. And can't wait to hear what it's like when you guys start using it.